This is a video tutorial for working with QGIS and introduction to geoprocessing tools. And in this particular video, we're going to be focusing on the basic geoprocessing techniques that we use in QGIS, how to calculate what's called feature geometry or geometry columns, also using the field calculator to do selections, and then also we'll do some SQL assignments to give value to some of the calculations that we make in our tables as a result of geoprocessing. So to get started, let's take a look at some of the lab steps that we'll be going through here. So our origination data will be 3 files. One's called Man Pluto or Manhattan Pluto. So we'll be using New York City and the Manhattan file for parcels. And we'll also be using Man Centroid, which is a centroid feature for Manhattan. And then also the buildings, Man Buildings. And what we want to do is also create an export folder. So I'll show you my folder in just a second. And so we'll be exporting a lot of things as we move along. And we're going to go through geoprocessing, doing a buffer. So we're going to do a 1 mile buffer. We're going to do 2 clips, one for the parcels and one for the buildings. We're going to do a union between those 2 clips. And we're going to do an intersection, and then we're also going to do a dissolve. And interestingly, there's a couple ways to do dissolves within QGIS. We're going to use the GDAL tools to do that, and I'll go through this when we get to that point to dissolve polygons. We're going to be also calculating feature geometry in the attributes, in the attribute table, and we'll go ahead and calculate it for area, which in this case is going to be feet, and then we'll change that to acres. And the calculation that we use for acres is right here. We can take a look at this other plugin. It's called Calc Area. That's a possibility too. If we want to use that, we can do that too. We're going to assign weights or assign values to our resulting square area. So in this case, we're going to decide, or let QGIS decide or figure out where acreage under 1 acre is, and we're going to give that a small value. Between 1 and 10, we're going to assign that a medium value. And for anything that's above 10 acres, we're going to assign that a large value. And we can do a lot of that work in the field calculator. And our final result will look something like this, where we've taken our parcels within 1 mile of our centroid, and we've just done a simple valuation for small, medium, and large within our attribute table, and then we've mapped that thematically. And oftentimes at the end of GIS processing, we'll want to get to some result that has meaning, and then we can categorically symbolize that or quantitatively symbolize the result. But somehow we're going to organize it in a way that's going to be an aggregation or a visualization that simplifies our GIS working process. And we'll oftentimes do that thematically in the map. I'm recording this lab guide right now, so this is essentially what will be on the lab sheet. And here's some visualizations of some of the things we're going to do here. So we're going to be clipping, dissolving, intersecting. We're not going to do a merge, and we'll also be doing a union. So down at the bottom of this sheet, you can actually see a visualization of some of the techniques that we're going to do. So let's go ahead and get started here. So the first thing we want to do is we want to just explore data, and then we're going to go ahead and do a buffer. So I'm just going to put this off to the side for right now. And let me show you how I have organized the data. So here I have a QGIS project saved, and I've called it C7. And then I have a data folder. So this is what you will download, and you'll have everything here. Man Pluto is the original parcel files for Manhattan. This is set version or 17, so this is relatively new data. And here is the Man Pluto shapefile, the centroid, and then the building. And then I've also created a folder called exports because we'll be exporting as we move along. I've also created in my browser panel a connection to the data. So I can just go ahead and start bringing it in. So the first thing we want to do is let's go ahead and just take a look at Manhattan so we have a sense of what we're actually mapping. So here's Man Pluto. And importantly, as I bring it in, you'll see that the coordinate system is, if we go to properties and take a look at it, we can see it's a user generated CRS. It has all the correct properties that we need, but QGIS doesn't see it as New York State plane. FIPS 3104, and it's good to have it see that particular projection because all our other data is in that projection. One of the critical bars to cross when you're doing GIS analysis work is that everything's in the same coordinate system. So instead of using that particular file, you should see Man Pluto 3104. So this particular file, if I drop it in, you can see that it changes the projection. So if I go down to properties, we can see that this is New York State plane FIPS 3104, and that's the one that is correct. Okay, and let's go ahead and now put in our centroid. So here's our centroid file, and it's just a dot that's sitting in the middle of Manhattan. And I was able to derive this from an outline of Manhattan and then just found the centroid of that particular polygon. So what we want to do here is we want to create a buffer, a 1 mile buffer around this point. So we're interested in properties that are within 1 mile of this particular, the center of Manhattan. So the way that we do that is we go up to Vector and we go to Geoprocessing Tools. And under Geoprocessing Tools, we're going to be using Fixed Distance Buffer. Okay, so there's Variable Distance Buffer and there's also Fixed Distance Buffer. For this particular video, I'm just going to focus on absolute fixed distance. So I want to make sure that my input layer is correct. It's easy to get these confused. So I want to have the centroid because that's what I'm buffering off, or I'm creating a distance from that particular location. Now it doesn't have to be a point. It could be a point, many points. It can be a polyline, many polylines. It can be a polygon or many polygons. Okay, so the input can be different types of vectors and different amounts of vectors. It doesn't have to be just one thing. And importantly, the distance is going to be measured in whatever projection system I'm currently in. And since I'm in 3104, New York State plane, FIPS, this is a feet system. So everything that's being measured in terms of distance is going to be in feet. So we want a mile. So 5280 feet is going to give us a mile. So that's our distance for this particular buffer. And on the segment count, the segments is an interesting feature of QGIS where the buffer returns not as a 100% perfect circle, but a polygon that has edges. And the more segments we have, the finer the circle is. Okay, so 5 is going to give us kind of a rough approximation of a circle. Something like 20 or 30 is going to give us a very round buffer. So I'm going to bump this up to 30 segments. And then I'm going to save this to file, and I'm going to call this to that folder. I'm going to call this 1 mile buffer. So 1_buffer. And say save. And say run it. Okay, it runs it very quickly, and you can see here it is. And if we zoom into it, we may actually be able to see, we can see right here on this edge, it's not perfectly round. There's just a little bit of a segment right there. So that's what's happening when we choose our segments. We want to make this pretty round. And your tolerance for how rough you want it to be is up to you. But since we want to get as exact as possible within 1 mile of that particular point, we're going to smooth it out with more segments. Our next step here is to go ahead and do some clipping. And we're going to clip both our buildings layer and also our Manhattan Pluto layer, the parcel layer. What I'm going to do for this video is I'm just going to go ahead and remove all of Manhattan. I just wanted to utilize the Manhattan file for all Manhattan Pluto just to show you where the data is actually coming from. So I'm going to remove that. And I have 2 features set up already that are selections within a mile, but they're not actually clips. So we'll see the difference here. So I'm going to bring in Man Building. So these are the buildings. And I'm also going to bring in Man Pluto. And what I'm going to do is I'm going to stick the buildings on top. I'm going to make them a different color. So let's style these. Let's make it sort of a red color. There we go. Okay. And then what I'm going to do for the buffer is I'm going to go down to properties and just make this a line. So I'll make my fill transparent. And the line, let's make that red. And we'll bump up the width. Okay. So what we have here, if we look closely, is we have currently a selection of both the parcels and the buildings, Manhattan Pluto and Manhattan Build. And that selection is within 1 mile. But as the selection takes place, it's selecting everything that intersects or touches that 1 mile boundary or the red line. What we really want to do with a clip is we want to cut very dramatically along the polygon itself. So we're literally severing or knifing out the polygon and separating it exactly at the 1 mile mark. So to do this, we use a clip function, and let's take a look and see what we get back. So we're going to do this both for Manhattan Building and Manhattan Pluto. So if we go to Vector and we go into Geoprocessing Tools, we're going to do a clip. Now the clip, you can run this as a batch process, so you bring both files in. For this video, I'm just going to run it twice so we can just keep track of what's going on. So the input layer in this case is going to be, let's do Manhattan Pluto first. And the clip layer is going to be the buffer. It's easy to get these confused, so just think about it for a moment before you actually enact it. And then the clip layer is going to be, let's just call it man clipped. And say save. And say run it. And we can see what we get. So the parcel layer is being cut right at the edge of the 1 mile buffer. That's what we want in this particular case. And oftentimes we want that because we're trying to create square areas within a very specific distance. That's usually what this process is amounting to, or oftentimes, especially with polygon analysis. Now let's go ahead and do it now for the buildings. So the buildings are sitting right here. Let's put them on top. Okay, we're going to cut along the buildings. So we go into Vector, we go into Geoprocessing Tools, and we're going to do a clip. Okay, come on clip, there it goes. So we're going to have the input layer be our Manhattan buildings, and the clip layer is going to be our buffer. And let's call this man build clip. I should have called this man Pluto clipped, the first one, but that's okay. Man building clip. You just want to have some type of naming convention that's going to help you distinguish what your outputs are. And we run it. And let's take a look and see what we get back. So we have a clipped layer here. There it is. So now we can see that we have both the building itself and the parcel clipped right at the 1 mile buffer distance. So our next geoprocessing task is to create both a union and an intersection. So with a union, what happens is that we take two layers and we bring those two layers together, and importantly, we are inclusive to the attributes, meaning we keep all the attributes of each layer. And our resulting geometry is also going to be very inclusive versus an intersect. So with the intersect, there's actually going to be a clipping process or an exclusion process as the two layers are merged. So let's just go ahead and do both those two actions so we understand the difference between them. So I'm going to clean up my table of contents here real quickly. So there was my original file, Manhattan Buildings. I'm going to remove that. I'm also going to, I'll keep on my buffer and keep on my man central, but I'm going to get rid of man Pluto here for right now. Okay, it's easy when you're doing geoprocessing work in the main window to get a bit confused with your layers if you have a lot of different layers, so try to keep it as simple as possible. So for the clip feature here on top, this is the buildings. So let's just go ahead and let's go to properties real quickly and go up to general, and I'm going to just call this buildings. Buildings clipped. Apply it and say OK. And then under properties, I'm going to call this parcels or Pluto. Parcels clipped. Say apply. OK. All right, so the first action we're going to do here is a union. So we go to Vector, we're going to Geoprocessing Tools, and then to Union. And we're going to be putting the input layer as buildings clipped. And the input layer, the second one, we can do as parcels clipped. And we're going to export it to, let's just call this a union. Save it. Run it. And this will take a moment because it's going to process a fair amount of geometry and also deal with the attribute table, bringing the attribute table together. So it's doing a lot of work behind the scenes, both on the tabular side, but also on the geometric side. It has to calculate where's there an overlay taking place, and then assign the correct attributes within the attribute table. So I'm just going to pause the video for a second here. We're at 20%. So here's union. Here's what we get back. So everything goes into one polygon, as we can see. So we have two layers coming into one polygon. And in this particular case, it's not really useful to us to have these particular features within the same layer. There's many times where union is really important, where a good example of that is that you have two different data sets that are categorically different, but you want to have them on the same layer. And so you've buffered around those particular categories. They might be points, and you want to bring everything into the same layer. That works. In this case, this doesn't really make sense logically to bring buildings into parcels. It might for some type of analysis, but not really for what we're interested in. But it demonstrates well what takes place here. So in this case, we have a little bit more than 30,000 records, and there's the actual attributes from the buildings. So this is what we're looking at right now. There's a bin number and a BBL. There's a height for the roof. And as we go along now and come across, then we actually get the parcel data that shows up also. So everything comes together into the attribute table, and where there's not an overlay, where there's not a building sitting on top of a parcel, then you'll get spaces in your attribute table like we can see here, where there's no attributes coming in. There's only attributes in this case for the map Pluto underneath. And this is, when you have these blank spaces, this is these areas where there's not actually an overlay between the two layers. Okay, so if we go back and take a look here, we can see that our green layer is not overlaying to the purple buildings. So in this particular case, it's only able to, when it actually does the union, to pick up the one attribute which is sitting in the parcel layer. It's not able to pick up the attribute of the building. It needs a spatial overlay to meet the condition of having both layers in the same attribute table. Okay. So let's go ahead and move along to our second overlay process that's probably more meaningful, and that's going to be an intersect. In this case, what's going to happen is it's going to just look at those locations where there's an intersection taking place. And of course, we have buildings on top of polygons for parcels. The logical overlay that's going to take place here is just the buildings. So we're going to get back a layer that's going to be just buildings, but it's going to have all the attributes of the parcel layer. And that actually would be really valuable to us. So if we wanted to find out who the owner is of a parcel, it's probably going to be the same owner as maybe the building, if the person owns the building on the parcel. There's also going to be information about the school district and about land assessed values versus building assessed values. So a lot of that might be really interesting to have into the buildings layer. And to do that, we'll do an intersect process. So let's watch to see how that works. So we go to vector, and we go geoprocessing tools. And here we're going to do a intersection, which is right up at the top. So the input layer in this case is going to be buildings clipped, and our intersect layer is going to be parcels clipped. And our intersection, let's just save it to a file and we'll call it intersect. And we're going to go ahead and run this. It goes quicker than a union does because it doesn't have to think as hard, because in this case all it's doing is trying to find where there's an overlay, and then it's tailoring the attribute table to that overlay. So it's getting rid of all the other things that don't actually see an actual spatial overlay. So let's click off all our layers and just look at our intersect here. So here we have buildings that have come back, essentially. And what we get in return, if we look at the attribute table, is now we have the buildings attribute, and we also have the map Pluto attributes here at the back end. So we can see here we have things like borough codes, we have FAR areas, we have historic districts. So all these kind of things would be really valuable to have in the buildings layer if we were doing mapping, say, for particular buildings, and we wanted to know attributes that were part of the map Pluto parcel database also for buildings. Okay, so that's the basic processes that we use. There's many more here. So if we go to geoprocessing tools, we can see that there's symmetrical difference. There's a dissolve, which we'll cover in just a moment. There's difference, there's eliminating sliver polygons and convex hull. I'm not going to cover any of those, except we do want to cover a dissolve. Dissolves are important. So with a dissolve, what happens is that we oftentimes have a category or a feature that we want to just collapse all the attributes. We're not interested in the actual attributes themselves, we're just interested in the geometry. So in this case, if we clicked on our buffer, and we wanted to just have all buildings square area, just the square area of buildings, we would do well with a dissolve, because we're not interested in what type of building it's, a particular building, what type it is. We're not interested in any of the Map Pluto attributes that are now in the intersection. All we're interested in is where are their buildings and what's the total square area of buildings. That's what we're going to essentially get back. So what we'll do is we'll do a dissolve process. Okay, so this brings us to dissolving, and dissolving is slightly more complicated than some of the other processes so far, at least from a processing point of view. So what's happening in a dissolve is we're taking a layer that can be relatively complicated, and we're trying to get rid of all the attributes, and we just want the geometry itself. So in this case, if we take a look at our intersect layer, so we had Mam Pluto plus our buildings, and we intersected those. And if we look at the attribute table, we can see that we have a relatively complex attribute table with lots of data, and we have 16,000 records, a little bit more than 16,000. So it's a big, complicated data set. The geometry is very complex, and what we want really is to get rid of all the attribute tables and just get back the geometry itself in aggregate. So we want to know within 1 mile of our point, what's the actual building footprint, regardless of the individual records. We just want to see it in aggregate. And to do that, we do a dissolve. And a lot of times we want to do a dissolve in the GIS process to calculate square area of some category or some particular attribute that's interesting to us. So in this case, my query would be, for this particular dissolve, logically, would be, give me back all square area that is a building, and it's got to be within a 1 mile buffer here. So let's kind of look at the tools that we can use to do that. So the first one is, if we just go up to vector and go down to geoprocessing tools, we could see it here as a dissolve. The issue with using the dissolve off the main toolbar here is that it tends to take forever for any relatively large data set. So if we were to run this on this particular data set, it can take, might take upwards of an hour. If we're just doing a small few polygons, this tool makes sense from this particular, the main menu here. Another option is if we go to processing and we go to the toolbox. Under the toolbox, we have some different options here. Let me bring these forth. We have some GDAL commands and then also some GRASS commands here also that would be appropriate. So under GRASS, there are some dissolve options here. So there's vdissolve we could utilize. Another one is under GDAL, under geoprocessing. So under the geoprocessing tab here, we have a dissolve polygons. And this one I find to be pretty effective. So let's do one run, and then we'll correct a problem that's very common within a dissolving. So here I'm going to put in, under dissolve polygons, I want to dissolve my intersect. And I can accept the default here. Now the issue is it's looking for a field to dissolve on. And it doesn't really give us the option to not be dissolving on the field, so I'm just going to run it as bin for right now. Okay, and I'm going to output it as multi-part geometries, because we can see that we're going to get back many disparate polygons, but we want all those polygons to be within one record. In that case, we'll pick multi-part geometries. If we know that we're just going to get back one polygon and one record, then we don't need to enact this particular option. And we can also compute area and perimeter for the dissolve features, which is a nice option to do also. So I'm just going to run this. I'm not going to actually save this file. I'm just going to bring it back into my layers panel when it's done. So let's just go ahead and run it and see what we get. So it runs, and I'm just going to pause the video. Oh, actually, I didn't even need to pause the video. It took like 2 seconds. So if we go up to dissolve now and look at the attribute table, it dissolved everything. It got rid of things. We're down to 7,836 records, but that's not really what we want. We really want a full dissolve into one record. So a way around this issue is if we go ahead and go back to our intersect and redo it, what we can do is set up a dummy column. So we'll go to properties and we'll go into fields, and let's go ahead and make a field. I've already made one as a test here. Okay, I'm going to go ahead and make a new field called test2. Okay, test2. And let's have this be a whole number, and we'll just call it 1. Okay, so each record's now going to have a column called test2, and it's going to have a record of 1. And say OK. And let's apply that and say OK. And we're editing currently, so let's toggle off that. So we're going to toggle editing, and we'll save what we just did. And let's go back and take a look at the attribute table. So if we go into attribute table, go all the way down to the end, you can see I made a column here before. I wanted to test it out before I put it on video here. Here's the test2, and you can see it's just ones all the way down through all our records of the full feature set, the original feature set before we did the first dissolve. Let's do the second dissolve now. So we go dissolve polygons, and this time let's input intersect, and our dissolve field, let's make sure it's our test2. So what's going to happen here, it's going to go into the field and it's going to look for records that are the same, and it's going to dissolve those. And since we have a record called or numbered 1, it's going to go through the whole thing, and it's just going to take all the ones and collapse them into one record. And that's exactly what we want. So let's go ahead and run this, and I'll save it as a temporary file and say run it. And it's going to take a little bit longer than the first time, so I'm just going to go ahead and pause the video. It says not responding. It's working right now, so I'm just going to let it work. And I'll be back in a second. Okay, so that took about a minute. And let's take a look at the attribute table now. So now we have one record. This is exactly what we want. So now we have one record that represents all buildings, or the footprint of buildings. And if we want to now, we could calculate our square area for just buildings. And that's essentially what we wanted to do with dissolve, is we wanted to get one record that we could utilize for another step in a GIS process or GIS processing to derive a meaningful result. Okay, so that's a workaround for dissolve, is just to make sure we have one column that's similar for each record. Okay? So let's go ahead and set up on our next step. So once we go through a series of geoprocessing steps, usually what we want to do is we want to calculate geometry, and we're going to do that together. And then we're going to, after we calculate geometry, let's go into the actual attribute table and start doing some interesting things relative to square area. Okay, oftentimes we want to do that in a GIS process, is that we want to categorize ranges or thresholds of values to produce thematic maps that are meaningful and nice aggregations of complex data that decision makers can utilize to make quick, important decisions without having to look at each record in the data set. They can just look at the spatial pattern and utilize the GIS process to come to a good decision based on the map. So to do this, let's take a look at the steps that we need to do. So the first thing we're going to do is we're going to go back to our original Pluto parcel. Okay, we're going to use that as our input. We're going to go to Vector, Geometry Tools, and then add a geometry column. And we're going to call that Area. So let's go ahead and do that right now. So I'm just going to actually make a new working. And I need to get my original, let's see, Man Pluto. Okay, so I'm going to bring Man Pluto in and say open. So what I want to do here is, if I look into my Open Attribute table, the Manhattan Pluto data set, there actually is, at the back here, there's a shape area column already established. But we're going to assume that you won't always have that, because oftentimes there's not a geometry column in vector data, and we need to know how to calculate that or how to create that. So even though it's sitting there, we're going to create our own. So we're going to make a new column called Area. Okay, we're going to go to Vector, and then we're going to go to Geometry Tools. And under Geometry Tools, we're going to go into Export Add Geometry Columns. and our man Pluto is going to be our input layer. We're going to calculate using this current CRS. So it's really critical that you know exactly what projection system you're in. So right now I'm in 102718, which is the New York State plane FIPS 3104 projection. Is the correct projection. And that particular projection is in feet. So all my area is going to be calculated in terms of square feet. And let's go ahead and let's just let it be a temporary layer. And we'll go ahead and run this. So it's going to give me a new layer, and let's go into the attribute table and see what we have. Okay, so now we have under area, we're just recreating basically the original shaped area that was in the Man Pluto data set. And what's nice is we can compare these two. We can see that we've done it correctly. So the problem here is that square feet's great, but it might be more meaningful given the size of the parcels to talk about acres or acreage. So let's go ahead and do that calculation. So we want to make sure that we have a unit of measurement that's going to make sense for the mapping that we're doing. So in this case, let's go to properties and let's make a new column. So we'll go into fields and let's make a new column. We're going to create a new field and let's see what we're going to call it. We're going to call it man area. So for Manhattan area, and our calculation here is going to be a decimal number. I need to make sure I have it right. Okay, decimal number. Okay, so I could just go ahead and create this new field right now, but let's go ahead and do our calculation. So what we're going to do is we're going to, remember we had the area column, so we're going to say area column divided by 43560, which is our calculation for acreage. Okay, so let's go ahead and run this and say okay. Say apply. Okay, and remember we're toggle edit on right now. So we're going to go ahead and save our layer edits. And then we're going to go ahead and toggle editing off. And let's go see what we have. So if we go back to Open Attribute Table, go all the way to the end here, we can see that we now have a Manhattan area. Let me zoom out here. That is our acreage. So we can see that we have some pretty small parcels, but we also have some that get into, there's an 838, which is probably going to be Central Park there. We have a 23, a 17, a 10, 9, 7. So some relatively large area. But we have a lot there in the 1 sort of 0.9, 0.8 range. So let's do this. Let's go ahead and we could simply map this thematically now based on those particular numbers. But oftentimes we want to categorize based on thresholds. So we might want to say, where are our small, medium, and large parcels? And we also may want to value an array of numbers based on good versus bad. We might want to have it be a concentration of risk versus not risk. So there's some categorical distinction in the array of data that we're interested in actually mapping. And we do a process to derive that human value from the large array of numbers in the attribute table. And so as long as we have a column, if we open up our attribute table of essentially continuous numbers, and we want to create thresholds that are meaningful in terms of a category, we can certainly do that. And that's the process that we're going to undertake here. And this is oftentimes the final step in the GIS process, is to give human meaning to all the working steps that we've done up to this point. Okay, and the basic steps for doing this are, first we have to actually create a field. So in this case, we're going to call it a value. It's going to be a text field. Then what we're going to do is we're going to SQL in our acreage. So we want to know all parcel areas that are less than 1 or equal to. They're going to be small. Then we want between 1 and 10. It's going to be medium. And anything that's above 10 is going to be considered to be a large parcel. And then what we're going to do is we'll go into Field Calculator and actually assign those values. And then finally, we'll thematically map them. So let's go ahead and get started here. So the first thing we need to do is actually assign a value. So we'll go to Properties, or I should say create a field to assign the values. So here, let's just go ahead and we're going to go right up here in the corner and add a new field. So this particular field is the name of it's going to be a underscore value for area value. And it's going to be text. Okay, so it's going to be text string. The length, we can go up to, let's make it 20 and say okay. And if we come down here to the bottom, we should see it added. There it is. That's great. Apply that okay. Save our edits. And then we're going to toggle off editing. Okay. Now what we're going to do is we're going to do some selections and then assign some text based on those selections. So the first thing we want to do is actually get into a selection. So we're going to select by expression. So in this case, we want to set this up. Let's go back to our sheet real quickly. So here's all our values. I'm just going to copy the first one. And I'm going to make sure that I'm in the correct field. Okay. So just going to put this in. So if I go take a look at, remember, here's the issue. If I go take a look, if I open up my attribute table, I actually named it differently here. So it's man area instead of acreage. In the sheet, it says acreage. I need to say man area. So let's go back. And so in this case, instead of, it's not actually that, it's going to be this column, man area. So man underscore area, okay, is going to be less than or equal to 1. And then what we do is we go ahead and select that. And you can see it selects it interactively here on the screen. And if we go into our attribute table, and take a look here, we're going to see that we have a bunch that are selected and then a bunch that are not. Okay, and the ones that are not selected, they are currently, they're cut right at once. So anything that's less than 1 was selected, or less than or equal to 1. And this is just a little bit bigger than 1, this one. So that was our cut point. Now what we want to do is we want to assign a value based on that particular selection. And to do that, we'll use the field calculator. So we can just go into the field calculator, and we want to go ahead and update an existing field. So in this case, it's going to be update an existing field. We're going to be updating our A value. Okay, so A value now is going to only update 7,358 selected features. Okay, this is critical to click on because we're updating what's currently selected in the attribute table, and we can see it on the screen here as currently selected. So in this case, we want to call these small. So it's going to be SMALL, and you can see I have a 1 quotation mark there. Okay, and let's go ahead and say okay. And then we'll go ahead and say save layer edits and toggle editing off, and let's see if it took it. So if we go back to the open attribute table and we look at what's selected, we can see that we have small now. Okay, we're going to do that over 3 times to get to our correct valuation. Okay, so the next thing I want to do is I want to go up to my selection, and actually before we do that, let's go ahead and make sure that we deselect all our features because we don't want to do selections on top of selections. So I'm going to get rid of everything that's currently selected. Okay, now I'm going to go back and create a selection. So in this case, if I go back to my original sheet, I want this calculation. And remember, I'm changing acreage to man area. So my fields and values, remember, I just called it man area here. So I'm going to put this calculation in, and I got to change it. So it's going to be man area, because there isn't actually an acreage column. Okay, and let's go ahead and run that. And that selects all these medium-sized parcels. And then we're going to go back into field calculator. And now it's only got 79 that's selected. That's fine. We're not going to create a new field. We're just going to update an existing field. And our field here is going to be a value. Now this is called medium. There we go. Say OK. Toggles on. Close this. Save layer edits. And then we're going to toggle editing off. We can go back and make sure that our selection looks good. So small, come down, and there's our mediums, and then we just have one left to do, which is going to be large. So remember, we're currently selected now. We don't want to do a selection on top of a selection, so we're going to deselect everything before we move on. And now we're going to go back and we're going to select by expression. Let's go back to our sheet. So in this case, it's going to be everything that's greater than 10. So I'll just copy that. Okay, it's going to be man area. Okay, it's going to be greater than 10. Select it. And you can see I just have a few that are greater than 10. And these are kind of arbitrary in terms of thresholds. So, of course, you could change the thresholds to be whatever you want it to be. So if we wanted to have everything that's between 0 and 0.5 acres is small, and then everybody that's above 0.5 acres is medium up until we get to say 6 or 7, and then from 6 or 7 on up would be large. We could do that also. So this is, our numbers are currently, there are criteria, but remember the criteria is depending on you as the analyst, or it's depending on somebody who's interested in your mapping has made that determination. Okay, let's go ahead and run that. So we selected it, and then let's go to field calculator. We have only 4 things selected currently. We're going to update the existing field. We're going to go into a value. And so for a value is going to be large. There we go. And say OK. It's going to toggle on. We go ahead and save layer edits. Toggle editing off. Go check it real fast. Bunch of smalls. And we see a few larges here. Okay, let's go ahead and clear our selection. And then let's thematically map. So at this point, I don't know if I've actually saved this particular layer, so let me just do a save as real quickly. I'm going to save it in New York State plane. I'm going to send it to my exports folder, and here I could call it, I'll just call it final categories, parcels, and say OK. Say OK. And let's go ahead and map this now. So we go to properties, and under properties, we're going to go style. Under categorized, we're going to go into our a value column, and we're going to classify it. It sees large, medium, and small. And this is any other values. We're going to click off any other values and say apply. Okay, there's our map. So here we can see the difference between what we called small versus medium versus large parcels. And if we go back to our worksheet here, there is one issue that I may not have clarified, and that is that we utilized the Pluto parcels, and the Pluto parcels were not at the end of the series of geoprocessing steps that we did. Oftentimes, at the end of the geoprocessing steps, you get to a result, and once you get to that result, then you want to do your area calculations and then go ahead and apply your values. Okay, so in this case, I didn't use the geoprocessing steps. All I did is just use our original Manhattan Pluto clip to simulate this final process of assigning values in the table based on criteria of acreage. So this is often the common flow of doing some analysis work, is that we get to a final result and then we want to categorize that result based on some criteria that we've either developed as the analyst or the researcher or the organization that we're working with has determined as appropriate to make the final thematic maps. And oftentimes the thematic maps are based on, say, risk, or they're based on relative sizes. There's something in the attribute that is a category that's meaningful to be mapped. So hopefully this is an overview of some of the geoprocessing tools that we use in QGIS, kind of showing where they're located and previewing some of them, and then also how we work in the attribute table once we've done a series of processes, GIS processes.